Well, hey again, everyone. This is Bob from Bossrox DIY Solar, and quite a while back, I did a video on putting a square wave bridge on a generator to run into a solar charger, and I never actually got that job completed. And today, we've had 4 straight days of solid crappy weather, and my battery banks are getting low, so I had to drag out the generator and hook this thing up and see if it was going to work. So just to show you here, this is a simple diagram of what we're doing here. You've got your AC from the generator coming into a square wave bridge, comes out DC, and a couple of capacitors to smooth out the ripple. And according to a capacitor ripple calculator, I would have had a substantial amount of AC ripple. So what they said is you need to put a choke in between the capacitors. And since I don't know anything about chokes, I read a little more and found that you can use a step-down, step-up transformer as a substitute. Well, I just happen to have one of those, a 10,000 watt one, because the choke you put in there has to be able to withstand the amount of amps that you're going to be passing through the circuit. So a 10,000 watt step-down, step-up inverter is strong enough to do that. However, I've already run the test, and to tell you the truth, the step-up, step-down transformer didn't do hardly a damn thing. So anyways, this is what the actual circuit looks like. There's my AC coming in, square wave bridge, and I've got 5 10,000 microfarad capacitors. And I put the step-down transformer in between these 2 capacitors here. And what I was able to do was by taking some wires off of that transformer, I could short them out and just bypass this completely to check whether or not running these all together or running it with this would make a difference. And what I found out was the step-up, step-down transformer didn't do anything. So I've eliminated the step-up, step-down transformer, and now I'm just running all capacitors. And to my surprise, the calculator saying that I'd have a 10-volt ripple didn't turn out to be the case. Let me show you what's going on here. Now, I've got the generator running right now, so I hope you can hear me over it. There's the oscilloscope, and that's the AC ripple I'm getting. And according to what it's saying, the voltage max is 0.20 at the most. So that's a pretty clean DC signal there. Actually, very little ripple at all. And I've got it running into my Grow Watt charger there, and it doesn't seem to have any problem with it. It's been running several hours now. And the only thing is that this is a 120 amp charger that I was hoping to get the full 120 amps out of. And this generator I've got is a 30 amp generator. And it turns out that running it at 30 amps was really stressing out the generator, so I had to cut it back. So I'm only actually able to get 90 amps. As you can see over here, there's what I'm getting out of the charger. So anyway, the experiment's a success, and this is one way that you can run a generator into your system through a solar charger, where you don't have to wire up your inverters if they have a built-in charger, or use a transfer switch and tie it directly into your electrical system. I think this is a lot easier. It could end up being costly though, because you've got the investment of a charger and the capacitors, which you can't see down there, but those big ass capacitors, 5 of them are $20 a piece, so it was well over $100 in capacitors. But I like this better because of the simplicity of wiring, and that's the way I chose to go with it, and I'm happy with my decision. So there you go, guys. Hope that gives you some info you can use in the future. Thanks for watching.